This is a key to page 1 of the review worksheet for 12.6 to 12.8, which is solving triangles, generally using law of sines and law of cosines. So number 1, we're supposed to find the length of side AB, which is opposite angle C, so I'll just call that side C. So I look and I know one angle, but it's not the angle between the two sides that I know. But one thing I know is that if I have a 30-degree angle opposite a 2-meter side in the same triangle, another 2-meter side has to be opposite another 30-degree angle. So I could say that the sine of 30 is to 2 meters as the sine of angle B is to 2 meters, and so angle B must also be 30, so angle C must be 120 degrees. So then I can use the law of cosines to find angle C. So, or side little c. So I would say that c squared will be equal to both of these sides, the sum of those two sides squared, minus 2 times the product of those two sides times the cosine of 120 degrees. So when I simplify that and take the square root of the value that I get to find the c, because cosine of 120 degrees is negative 1/2, I get that c is equal to the square root of 12. So I could write that as 2 root 3, or in decimal form that would be 3 46/100ths in length, units. Okay, so then for number 2, to the nearest degree, what's the measure of the smallest angle? So the smallest angle is always going to be opposite the shortest side. So we're looking at the measure of angle Z. So because with angle Z, I know the two sides that angle Z is included between, I can use the law of cosines. So I can set this up as the cosine of angle Z should be equal to the sum of those two sides squared that form angle Z minus the square of the other side over 2 times 8 times 7. So then that's going to lead me to the cosine of angle Z is equal to 77 over 112. So Z will be, because I'm finding an angle, the inverse cosine of 77 over 112. So in this case, Z will be 46 6/10 degrees. So I'll box these. Okay, continuing on. In number 3, we're actually given the sine, the value of the sine of an angle R and the value of the sine of angle Q. So I'm supposed to find the length of PQ in centimeters. Well, PQ is opposite angle R, so I'm going to call that side little r. So I do know the sine of this angle and the sine of this angle, so I can't use the sine. The law of sines, I can say the sine of angle R is to side little r as the sine of angle Q is to 5. Okay, and I know the values for the sine of R and the sine of Q, so substituting, I can say 1/4 is to R as 2/3 is to 5. And then cross multiplying 5 times 1/4, 5/4 is equal to 2/3 R. And multiplying both sides by 3/2 to isolate the R, I get that R is equal to 15 over 8. And we'll leave it at that. Okay, number 4. To the nearest whole number, how long is the missing side of the triangle? So I'm looking for this side opposite a known angle that's included between two sides. So side angle sine, I can use the law of cosines. So I'll just call this C, side C, for now. So C squared will be equal to 18 squared plus 28 squared minus 2 times the product of 18 and 28 times the cosine of this angle, which is 41 degrees. So when I punch that in and take the square root, I will get C is a length of 18.6, 18 and 6/10. Okay, number 5, to the nearest degree, what is the measure of the largest angle of the triangle? Well, the largest angle is going to be opposite the longest side. We don't know all three side lengths. We do know that this side is bigger than this side, so this angle will be bigger than 44 degrees. So let's for now just make this angle A and use the law of sines. So I can say that the sine of this known 44 degree angle is to the known length of 16, as the sine of angle A is to the side of 23. So cross multiplying, 23 times the sine of 44 degrees equals 16 times the sine of A degrees. Dividing both sides by 16, I will have, and switching sides, sine of A is equal to 23 times the sine of 44 all over 16. So A will be the inverse sine of that ratio. So angle A will be equal to, well, it's going to round to 87 whole degrees. So if that's 87 degrees and this is 144 degrees, then altogether that's 131 degrees. So it leaves 49 degrees for the third angle. So that is the biggest angle of the triangle, angle A, and it is 87 degrees. Okay, in number 6, we're supposed to find the measure of QR. QR is this side opposite angle P, so I'm just going to call that little p for now. And I can use the law of sines. This angle is known because if these two, 70 and 60, add to 130, then this angle P will be 50 degrees. So I can say the sine of 70 degrees is to 5, as the sine of 50 degrees is to side P. So cross multiplying, P times the sine of 70 is equal to 5 times the sine of 50 degrees. So P is equal to 5 times the sine of 50 degrees all over the sine of 70 degrees. Okay, so that you could have the answer in that form if you were asked to find it in that form, or you could simplify it to find that P has a length of 4.0 units. Okay, number 7, triangle ABC, A is 5, B is 8, and C is 60. So I'll just make a triangle with it. I'll make this a 60-degree angle. It should be acute though, not obtuse. And A and B and C, and side A is 5 and side B is 8. So I'm supposed to find side C. So this is a case for the law of cosines. Two known sides with an included angle, so it's side angle side. So side little c squared is going to be equal to 8 squared plus 5 squared minus 2 times the product of 8 and 5 times the cosine of 60 degrees. Well, the cosine of 60 degrees is a half. We know that that's one of the special angles. So anyway, when I get this, I'll get c squared is 49, and taking the square root, c will be exactly equal to 7. Okay, number 8. Given triangle ABC with A equal to 2, B is 45 degrees, and A is 30 degrees. So I'll try and draw this a little better here. So I'll make like a 30-degree angle. That's angle A, and I'll make the side opposite that angle equal to 2, and then angle B, I'll make this angle B at 45, and that's it. So I'm supposed to find the length of side little b. So this is an easy case for, I've got an angle with a known side and then I've got an angle with an unknown side, so law of sines. So the sine of 30 degrees is to 2 as the sine of 45 degrees is to side B. So after simplifying it, I won't go through all the algebra, you're going to cross multiply. You'll end up with B is equal to 2 times the sine of 45 degrees over the sine of 30 degrees. Okay, and then when you simplify that, if you leave it in simplified radical form, you'll get B is equal to 2 root 2. Or, let's see, the decimal equivalent would be 2.83 units. Okay, number 9. Triangle ABC, according to the sine law, what does B equal? Well, you could do this in terms of A or in terms of C, but I'll just do it in terms of A. I'll just say, well, the sine of A is to A as the sine of B is to B, and then I'm just going to do, the cross multiplication. B times the sine of A is equal to A times the sine of B, and then when I divide both sides by the sine of A, I will get B is equal to A times the sine of B over the sine of A. So that's just expressing B in terms of angle A and angle B and side A. Okay, and the last one, number 10, in triangle ABC, A is 951, B is 61. Okay, so let's make a little triangle here where I'll put C up here, A and B. So C is a 68-degree angle. This side is 631, and then side A is 959. So I'm supposed to find the measure of angle A. Well, I can't use sine law yet because I have an unknown angle measure and a known side, and I have a known angle, but I don't know this side here, and I don't know what angle B is. So this is going to be 2 steps. So I will take this out to the side here. Let's redraw it. So I have 68 degrees, 631, 959, A, C, and B. And ultimately I have to find the measure of angle A. So this is number 10. So first I'm going to find side C using the law of cosines. So C squared is equal to the two sides that form this angle, 959 squared plus 631 squared minus 2 times the product of those times the cosine of 68 degrees. So when I solve this, I'll get C is equal to 929 and 76 hundredths. So for now I'm going to round that because I think that's, I'll just do that. So I'm going to put 930 because these are expressed in whole numbers. I'll put that as a whole number. So now I can use the ratio 68 to 930 and the A to the 959 to find the measure of angle A. So now I'm going to use the sine rule. So the sine of 68 degrees is to now the known length of 930 as the sine of angle A, unknown, is to the known length of 959. So cross multiplying 930 times the sine of angle A is equal to 959 times the sine of 68 degrees. And dividing through, so sine of A is this ratio, so A is the inverse sine of this ratio. So when I punch that in, we'll get that angle A is 72 and 96 hundredths degrees. So we'll just, to the nearest whole degree, that would be 73 degrees. So that's it for side one of this review worksheet.